షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.
Today, I want to give a brief description about the topic circuits. Before entering into the topic, I am asking you some questions. Have you ever observed what type of connections are there in the headlights of the car? Do you know what type of connections are used in our household electrical appliances? And which type of circuits are connected in the serial sets? Yes, today we are going to learn about the circuits topics and what types of connections in the circuits. Okay, and now you all know that in the electricity lesson you all are familiar with the terms. One, current, that is I, denoted with letter I, and another one is potential difference, V, and the next one is R, resistance, and next one is the factors of the affecting the resistance of the material, factors affecting R, and another one is Ohm's law. Now, using all these terms, we will know the types of circuits and what type of connections are used in the circuits. Or what is circuit? Circuit is a closed path connecting the, see here I am drawing the diagram. Circuit is a closed path. See here, circuit. What is meant by circuit? Circuit is a closed path created by the connecting wires through a battery along which electrons can flow. Electrons can flow along these wires and it is connected through a battery. This closed path of the connecting wires is called as a circuit. And we all know that in the circuit, if the circuit is opened, then the bulb which is connected in the circuit is off. If the circuit is closed, then the bulb will glow like this. Okay. And so many different devices used in the circuits are also called as components. And using these components, we can make so many connections. Generally, there are three types of connections are there. One is series connection. Second one is parallel connection. And third one is the combination of this series and parallel connection. Series and parallel connection. Topics are, one is, now we are going to know about the series connection, parallel connection, and third one is deducing the expressions for the equivalence resistance. In these two types of connections. Let us start with series connection. What is meant by series connection? I will introduce the series connection by a small story. Let us see that here are two places. One is X, another one is Y. That is two cities are there, X and Y. And three people wants to move from X to Y. And there is only one path is there. But there are three connecting roads between these two cities. First connecting path, second connecting path, and third one. And three are moving in the same path. and these three will reach at the end of this paths by moving on the same path. In this manner, here also, so in series connection, if you observe, the bulbs will connect like this. That means the one end of the one bulb is connected to the other end of the second bulb. Next one, minus is connected to plus, again plus minus, minus to plus. In this manner, if the connection is there in the bulbs, then it is called as a series connection. And the next one, if you take the second one, that is called as parallel connection. In the parallel connection, what we observed that these are again the in between the two cities, there are three ways are there for moving from one city to another city, and these all three friends are moving in three different paths. All are moving in the three different paths, but they will reach to the end of the path, that is Y, that means the second city. Okay, here in this movement, the I current will divide in three paths, but whereas in series you are observing only one path is there for I. For deducing all these expressions, now we will draw the circuits. For series connection, see the bulbs which are connected in the series. This is plus minus plus minus plus minus. If all the components are connected from one end to another end just like this, then it is called a series connection. What happened about, we will find about the I and V. What is I here? The current which is passing through this three bulbs is same, only one path is there. So in this manner, in this connection, series connection, I is always constant. But what about the V? We can take the different potential difference for these bulbs. So if it is V1, if it is V2, if it is V3, by using multimeter we can find the potential differences among all these three bulbs, and if you find the total potential difference at the end of the wires, that is called as V. Then what will you observe? We will observe that V is equal to V1 plus V2 plus V3. The sum of all the potential differences across these bulbs is equal to the V. So here in the series connection we got one formula, that is V is equal to V1 plus V2 plus V3. We observed, and I is constant. By using these three, we will find the equivalent resistance among the three resistors. So again I will draw this one. See here, this is the symbol for resistance, and another one is like this. If three resistors are connected like this, and we are naming this one as R1, R2, R3. Again what happened? Same, I will flow among all these three resistors. That's why it is same. I is constant in this connection. And next, if you see, what about the V? You want to check the V here. That means always voltmeter will use it to find out the potential difference, and it is always connected in the parallel. Again you take this one. This is called V1. You will get it like this, and this is V2. And you come to the V3 like this. And find the total difference in light. And this is the circuit, which is the series connection, and resistors are connected like this. Now we are going to deduce the equivalent resistance for this series connection. What we know, according to the Ohm's law, we know that V is equal to IR. What is V? Potential difference. What is I? I is equal to current. What is R? R is resistance. And what formula we are having for series connection? V is equal to V1 plus V2 plus V3. So first of all, we just find V1, V2, V3. So substituting V1, here it is IR1. This is the first equation for this resistance. The potential difference in this resistance is V1 is equal to IR1. And for this is V2. V2 is equal to IR2. It is the second one. In the similar manner, what about V3? V3 is equal to IR3. I think you all observed that here I is constant. We all know that in series connection I is constant. So I is there. We are not naming as I1, I2 or I3. Simply V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR. So if for equivalent resistance, if there is a resistance which is equal to the series connection, then it is called as V. And for V, it is V is equal to IR. So substitute all these values in this equation. What we will get? See, V, in the place of V, we are writing IR. In the place of V1, IR1. In the place of V2, IR2. Place of V3, IR2. See, in all these terms, I is common. So take I common, then it will become R1 plus R2 plus R3. Here it is IR. Eliminating I on both sides, then what you will get? R is equal to R1 plus R2 plus R3. And we are saying that this is the equivalent resistance. That's why you just keep it as EQ. So Req is equal to sum of the all three resistors, individual resistances. So this is the equation for equivalent resistance for the resistors which are in the series connection. Parallel connection, the bulbs are connected like this. Here the positive end of each bulb is connected to one end and the negative end of the another each bulb is connected to the other end. And these ends are connected to the battery. Then this type of connection is known as parallel connection. Now we will draw the circuit for the parallel connection. This is bulb 1, 2 and this is 3. And here are all positive sides, negative ones, and these are all connected to the same end. And these are all connected to the same end. And again these will drawn like this and they are connected to the battery. And this type of connections are known as parallel connections. See, in this parallel connections, what happened? What about the I and V? See here, we are observing this. When the current is passing in this direction, when it enters into this point, here I is divided into three ways. That means it is moving in the three ways. I1, I2, I3. So here, if you want I, then it is the sum of all these three, I1, I2, I3. So what is the equation here in this parallel connection? I is equal to I1 plus I2 plus I3. If you want to see the voltage is the same. Why? Because these are all connected to this end and this end. If you want to find out the voltage, then you take these 2 points. Then it is a constant. So V is constant in parallel connection. And if you want to draw the picture, draw the circuit, schematic diagram for this resistors, how will you draw? Take 3 resistors. And we understand that in each way I is different. So for measuring I, what you will put? You will draw ammeter. Ammeter is always connected in series connection. So we just draw like this and connect all these 3 to one end, another one to another end, and draw it like this. This is for resistance. Here I is different, V is constant. Now we are going to deduce the expression for the equivalent resistance in the parallel connection. Again we know that V is equal to IR, but we don't want any VR, we want I. For getting I, what will you do? I is equal to send this R, then it is become I is equal to V by R. Then the expression for I is equal to V by R. Then what for I1? For I1 it is V by R1. What for I2? I2 it is V by R2. What for I3? V by R3. And see these all three equations. What we are observing in all these three, V is constant because it is in parallel connection. So from this formula, if you substitute all these values, then you will get like this. V by R equal resistance. V by R is equal to V by R1 plus V by R2 plus V by R3. Again we are seeing that V is common in all the numerators. Take common, then you will get it as V into 1 by R1 plus 1 by R2 plus 1 by R3. Eliminating V, what you are getting? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Again this is the equivalent. So reciprocal of equivalent resistance is like this. So equivalent resistance of equivalent resistance in parallel connection is less than equivalent resistance in parallel connection is less than the each resistance. So this is the expression for the equivalent resistance for the resistors in the parallel connection. So here in this parallel connection, if you observe, if there is a break in this connection, what happened? The two will glow, the rest of the two will glow because the current is passing not only here but also here and here. That means there are three paths are there for flow of current. So another connections are closed, that's why they will glow. In this manner, we use this parallel type of connections in our electric circuits, household for household appliances, and we also use this type of parallel connections in our headlights of the cars. Thank you one and all.